Hey guys, welcome to my channel Coding Shinobi. Today we are going to start with a new topic that is linked list. And this questions is to see where you are at linked list and you might get in your interviews as well of like basic DSA questions. Also, we are going to code these questions in IntelliJ in Java. All the coding stuff I'm going to take care in Java only. And if you want me to increase the complexity of the questions too, let me know in the comment section. And as of now, let's get started with the video. So our first question is, you are given a head of a linked list and you have to traverse on in a singly linked list. Usually, how do you represent an array? This is how you represent an array in memory. It has got the contiguous memory locations, right? And how do you calculate the index in array? You know the base address of this zeroth element, and if you want to access the third element, then get the base address plus 3 into whatever is the size of the int. In Java, it's 8. So this is how you can get the base address of the element in an array. Now, how linked list is represented? Linked list has a different structure. It is represented by nodes. These are known as nodes, and these nodes are not necessarily contiguous. If you create a new node in a memory, your first node can be created here, your second node can be created here, your third node can be created here, right? So how do you know like this node is linked to this node and this node is linked to this node? So in linked list node, you have two parts. The first part consists of your data, whatever data you want to store. As we store, like there is an array of integers, array of strings, and we store the data in at the index, right? Whether it be integer, string, whatever it is. So this is how your data will be stored. And this part is used to store the address of next value. So if this linked list, this node is connected to this node and something like this, then address of this node is contained by this node. So this is the address of next node. And what will be the address of last node? It will be null. This is basic introduction about linked list. I hope you know what are linked list, and we'll continue with the solution of this question. Now, next thing you need to know how to represent a node in Java, right? What we can do is we have these two things that we need to cover in our list node. We'll call that node as a list node. We will create a new class in Java which will have two properties. It first will be of type int. We will take as type int for now. It could be string, anything you want, whatever data your node wants to represent. And again a next node, because this will contain the address of next element, right? And I'll just add a constructor. This is how your list node, this is how your linked list node will look like, right? It will have data and it will have the address of the next element. How will your function look like? So this is something you are just given a head of the linked list and you have to traverse using this information on that. You have to traverse the list using the head that is given to you. Now, for example, this is a list you have been given and you have to print this list like this 8351. What all information you have now? You have this head, and using this head, you need to traverse through the whole linked list. What does this head contain? Head has its own value, it has some val, it has its data, and it also has the address of the next element. So using this information, we can traverse through the whole linked list. What you can do in the beginning is you can print this value head dot data, and then you will move this head to the next element. How we can move to the next element? You can assign this value to your head, right? Then head will contain the information of the next element. Head is equal to head dot next. For example, your this thing is situated at 120th address, and currently the address of this node is 100. When I do head is equal to head dot next, means my current value of head is at 100. 100 dot next is 120. So my head becomes 120 now, meaning my head points to this next node, right? So till when we can do this? We can do this till my head is not null. While my head is not equal to null. I'm doing this. So whenever your head becomes null, your loop will exit and you will print this data however you want, right? Now, guys, do you see any problem in this code? You are given the head of this linked list and you are modifying the head itself. You don't have track of what your head of you don't have track of the head of your own linked list, right? So instead of using head for the traversal, we can have a temporary variable, assign the head to it, and then traverse through the whole linked list. What I mean is, I will have this temp variable, I am assigning head to it, and then using this temp variable to traverse. So you already know the head of this linked list, right? Sometimes in interviews, your interviewer will ask a question wherein you have to return after printing, you have to return the head of your linked list. In that case, you cannot use head, right? And it's a very good practice to use a temporary variable, assign the head to it, and then do all of your operations on your linked list. Because most of the times you go wrong when you actually modify the head of the linked list. Maybe if you'll solve more questions, you'll get the hang of it. Now let's code this thing and see this in action. So this is my list node wherein I have data of type int and I have address of the next element. And I have also added a constructor to create the list node. Now also I have this class linked list wherein I have created this method traverse which will be used to traverse the linked list using head. And I have created a linked list as simply. We will see, if you want, we can also cover the insertion part later. But right now, I have created a head with next address null. But again, I'm updating the address of the next element of this head with a new list node. Then I have created a linked list which contains our data 8351. Wherever there is an parameter for the next address, like as I have as mentioned in this constructor, I'm just creating a new list node at that place in the constructor itself. Now I'm calling this method traverse on head. It should print 8351 space separated. As you can see, we have successfully printed the linked list. Let's move on to the next question. Okay, so our next question is calculate the sum of a given linked list. You have to calculate the sum of all the nodes in a given linked list. Like let's consider the same linked list that we had already seen. We have this 8, 3 plus 5 plus 1, which comes out to be 17, and we have to return the 17. As simple as that, right? You have given your function will look like this, something like this, and sum, and then you have given the node of the linked list, and then you have to calculate the sum and then return. Pretty straightforward, right, guys? Here in the above example, we were just printing out the data while traversing the linked list, right? Now, what we have to do, we can just calculate the sum plus is equal to temp dot data, right? And then traverse the linked list till the your temp goes null, and then you can just return your sum from here. I don't think we need to write a pseudocode for this. Let's just code directly and see if we can do this in via code or not. So guys, I have written this function sum which will take head as the input and calculate the sum of that linked list based on that head. And I'm just calling this sum method and printing whatever sum that it returns. Also, guys, if you have noticed, we are again using this head and calculating the sum. So if we have used head instead of temp here, then our head would have been modified and your head would have become null. So you again had to create the linked list and then calculate the sum of that linked list. Let's run this program. Now the sum is 17 of this linked list. What if like I want to have another node attached to it, like let's say 13, and x dot is equal to null. Let's see the output of this program. It's 30. Let's move on to next question. So guys, our next question is given a head of the linked list, print nth element of a linked list. Now you have given this linked list, and when n is equal to 2, you need to print 3. If n is equal to 6, but we have only 5 nodes, then in that case you can print -1. um, you can print -1, or the node does not exist in your liquid, or it exceeds the size, blah blah blah, whatever it is. If n is equal to 3, then what will you print? You'll print 5. If asked by the interview, you can give the input validation, like uh, if the input is less than 0 or less than equal to 0, then say ki just return the control from there, then and there only. But if it is greater than 6, then you have to return -1. If sorry, if it is greater than the size of your linked list, then you have to return -1. um how your function will look like. So your function name is print nth element, and it is returning the nth element, and you are given the head of the linked list. First step, introduce temp variable and assign head to it. Now you need some kind of counter which will keep track of which element we are in the linked list, right? First, at in the beginning we are at the first element only. So our counter, also you have been given nth element, of course, right? Sorry, my mistake, I didn't include it in the beginning. And then I have this count variable. We are at first element, so my count variable is 1. Now my while my temp is not equal to null, I'll check if my n equal to count first. If it is equal to, then I'll just return the data. But if it is not, then I'll increment my count and move my temp variable to the next. Now guys, tell me, if my n was if my n was in the size of the linked list, it would have returned the data from here itself, right? Since it is not returning data from here, means, and it is exiting the loop and coming, your control is coming here, somewhere here, then it means that your n is greater than the size of your linked list. So in that case, you can return -1 from here itself. And what will be the time complexity of this, guys? It will be the size of linked list, right? Let's say the size is m, and space complexity is 1 because we are not using any extra space. Let's code this. So this is your code. I have introduced this method print nth element. I have this head and the nth number that we want to return. I have assigned my head to temp variable. Initially my counter is 1. If my counter equal to n, then I'll just return the I'll just return the value. Otherwise I'll increment it. I'll just move on to the next node. Otherwise, if my n is not in the size of within the limits of my linked list, then I'll just return -1. Let's run this, and it should print, since I am passing 6, n is equal to 6, and my head, it should print -1. Let's see what is the second element. Second element is 3. 8, 3, 5, 1, 13. What is the fifth element? It should print 13. 13. So guys, this was all about the linked list traversal questions that I had to cover in this video. There are many more, but if you want if you want me to continue with this linked list wala series, we can increase the complexity of questions. We can see the insertion, we can see the deletion in a linked list, and whatever you guys want, just let me know in the comments. If you want me to improve on something, if you're not understanding anything, if you want me to decrease the pace, increase the pace, whatever your feedback is, let me know in the comments. And I hope you learned something from this video, and I wish you all the best for your interviews. See you in the next video. Bye bye.